In this video, we'll be going over right triangle trigonometry. So to begin with, let's review what a function is. So you talked about functions in your algebra classes, and we use this word a lot, but it's important that we have a good understanding of technically what a function is. So the basic, or the one way that you can think about this for the purposes of this class is that a function has an input, typically it's a numerical value or a real number, and then something happens with that function. Let's say the function is named f of x, and then we get an output. Okay, so the input, the values that can go into a function is called the domain. The values that come out of the function are called the range. All right, so when we have, let's talk about a common function. Let's say I have f of x is equal to square root of x. Okay, so the numbers that we can input take the place of the x. And in this particular function, we can input positive numbers or 0. We cannot input anything that's negative, cannot input a negative value. Okay, so we have positive numbers and 0 that we can input. We do not input any negative numbers. So it's important to remember the types of values that we can input into a function. So we need to keep these characteristics of what a function is as we start talking about new types of functions, namely the trigonometric functions. So let's look at this image, and we define, or there's a few different things happening on here. We have a right triangle. We have a length of x for the base. We have a height of y for the height, and then a value of 1 for the hypotenuse. This point that is on the curve has coordinates x comma y, right? It's x in the horizontal direction, y in the vertical direction. And then we have an angle, central angle down here, angle t. So the trig functions, or trigonometric functions, are defined by these three values. So defined by an angle t, and then side x and side y. So suppose we're standing here at angle t, okay, and looking out kind of this way. Okay, so what we'd say is that side y is opposite of that angle. Opposite. So y is the opposite side of that angle. Side x is next to that angle, so we say it's the adjacent side. And then this side over here, side 1, well, we already said that that's the hypotenuse. Okay, so there are 6 trig functions that are based on a relationship between the angle and the sides of this right triangle. So those trig functions are sine of angle t, cosine. Actually, let's not write the angle just yet. So sine, cosine, we have tangent, cotangent, and then we have secant and cosecant. Okay, so these are the 6 trig functions, and what happens with these functions is the input of a trig function is an angle. Okay, so this is very important. So the input is an angle, the output is a ratio, or a coordinate. Okay, so this is kind of the big idea with what we're talking about here. So when we have a trig function, the input is an angle, the output is a ratio of the sides of a triangle, or a coordinate value. So let's talk about what each ratio is for each of these trig functions. So for sine, we abbreviate sine as SIN. The input is the angle t, okay, and sine is defined as the opposite side of that angle divided by the hypotenuse. So looking at this diagram, the opposite side of angle t is y, the hypotenuse is 1. So y over 1, or just y. Okay, so when the hypotenuse is equal to 1, right, we just need to think about the opposite. So for cosine, we abbreviate that as cos. T is the input, so the angle. The ratio for cosine is adjacent, adjacent divided by the hypotenuse. So in this diagram, the adjacent side from angle t is x divided by the hypotenuse, which is 1, which is just x. All right, and then moving over to tangent, we abbreviate tangent as tan of the angle t. Tangent is opposite over adjacent. Okay, so in the diagram, opposite side is y, the adjacent side is x. All right, so these three functions, sine, cosine, and tangent, these are the basic functions, or the fundamental functions. The other three, cotangent, secant, and cosecant, are the reciprocals. So each of these are just reciprocals of one of the first three. So cotangent, that is the inverse of tangent. So cotangent of angle t is just the inverse of what we had up above. So that's adjacent over the opposite side, so x over y. Secant, that's reciprocal of cosine. Okay, so secant is SEC of angle t. The reciprocal of cosine down here is going to be hypotenuse over adjacent, which is going to be 1 over x. All right, and then cosecant, that's the reciprocal of sine. So cosecant, we abbreviate as CSC of angle t. So sine was opposite over hypotenuse, so the reciprocal of that is hypotenuse over the opposite side, which is going to be 1 over y. All right, so this will make more sense once we go through an example here. All right, this example says to find the value of the 6 trig functions for theta in the given triangle. Okay, so we have a right triangle. I should have said back here, these trig functions, these ratios are only going to work in this way when we have a right triangle. So you might want to make a note of that. Only work for right triangles. Okay, that's important. If we don't have a right triangle, there's other things we can do to find side lengths. But for right triangles, this is what we want to be using. Okay, so we have a right triangle, and what we want to do is we want to find the trig function value for theta, the 6 trig function values. Okay, so again, the angle goes into the function, so we're going to say sine of angle theta. Well, remember, sine is the opposite side, which is going to be 12, divided by the hypotenuse, which is 13. So this is 12 divided by 13, and that's it. Cosine is the adjacent side divided by the hypotenuse. So this is 5 over 13. And then, let me erase that. And then the tangent is the opposite side over the adjacent side. So opposite over adjacent is going to be 12 divided by 5. And that's it. So we've gotten 3 of the trig function values. And then to get the other three, we're just going to use the fact that these are reciprocals. So cosecant of theta is the reciprocal of sine, so that's just 13 over 12. Secant of theta is the reciprocal of cosine, so that's 13 over 5. And then cotangent of theta is the reciprocal of tangent, that's 5 over 12. So really what you should do is you should remember the ratio for sine, cosine, and tangent. And then just remember the fact that these are just reciprocals of the first three. I wouldn't recommend necessarily memorizing that cosecant is hypotenuse over opposite. Just remember that sine and cosecant kind of go together and that they are reciprocals. So now is a good time to mention, well, how can we remember what the ratios are for these first three? Well, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So one way that people memorize this is sine is opposite over hypotenuse. So we have SOH, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Tangent is opposite over adjacent. So for some reason, this phrase, SOHCAHTOA, is easy to remember for a lot of students. This is a way that people can remember the ratio for sine, cosine, and tangent. So, SOHCAHTOA. All right, another example here. It says find the value of the 6 trig function values for theta. Now in this right triangle, we only have 2 of the values. We need to find the hypotenuse. So in order to find the hypotenuse, we're going to use the Pythagorean Theorem. So 5 squared plus 8 squared is equal to this side c squared. If you don't remember, the Pythagorean Theorem is a squared plus b squared is equal to c squared. All right, so we need to figure out what c is equal to. 5 squared is 25, 8 squared is 64, 25 plus 64 is 89. So c is equal to the square root of 89. I don't think we can simplify that radical at all, so let's call it square root of 89. All right, so now that we have all 3 sides, we're going to proceed just like we did in the previous one. Sine of theta, cosine of theta, tangent of theta. And then from after that, we're going to find the reciprocals. So cosecant of theta, secant of theta, and cotangent of theta. So I recommend you pause the video here and see if you can figure out these 6 values. All right, here are the 6 values. Couple things to mention. Notice that all 6 values are different. So none of the 6 values should be repeated. So that's true here. A second thing to notice is look at the sine and cosine values. We have a radical or square root in the denominator. You may have learned in previous classes that we don't want square roots in the denominator. Sometimes you may have heard it said we need to rationalize the denominator. This just means make a rational number instead of an irrational number. Oops, we don't want to irrationalize the denominator. We want to rationalize the denominator. It is an irrational number already. So we want to rationalize the denominator. You may have heard that said in one of your previous math classes. I am not very strict on this. I don't actually think it matters. But if you want to rationalize the denominator, what we do is we multiply the top and the bottom by the square root in the denominator. So we get 8 square root of 89 divided by 89. Similarly for this one, we're going to multiply the top and bottom by the square root in the denominator. We end up with 5 square root 89 divided by 89. So if you feel as though you want to rationalize the denominator, go for it. I don't think it's that important though. So for sine this value or this value would be accepted for full credit. All right, this example says to find the missing sides of the triangle with cosine of angle B equal to 0.6 and side A equal to 21. So I just drew the right triangle here with side A equal to 21. So a couple things with how we label triangles. We use capital letters for angles, so that's why B is a capital letter. And then the sides that are opposite of each other are the same letter. So B and B are opposites, but we use lowercase letters for sides. So lowercase a, B, and C are all sides. And then capital letters for angles. So this angle would be capital A, this one would be capital C. All right, so we want to find the missing sides. So we need to figure out what side B and side C are equal to. Well, the information we have is cosine of angle B is equal to 0.6, but we also know that cosine of B is equal to the adjacent side over the hypotenuse, which in this triangle, from angle B, the adjacent side is A, and the hypotenuse is C. So this is going to be equal to A over C. So cosine of angle B is equal to 0.6. Well, 0.6 is equal to A over C. So 0.6 is equal to A, which we have, but we don't have side C yet. So I can multiply both sides here. 21 divided by 0.6, we get 35. So that is side C. Okay, and now that we have two sides, we can use the Pythagorean Theorem. So we're going to say A squared plus B squared is equal to C squared. So 21 squared plus B squared is equal to 35 squared. You're going to need to use a calculator most likely to do this. So we get B squared is equal to, let's see, 35 squared minus 21 squared, 784, and then take the square root of that, and we get 28. So B is equal to 28. And that's how you do that. One thing you want to check here is that the hypotenuse is the longest side. In a right triangle, the hypotenuse is always longest. So hypotenuse is 35, that is longer than either of the other two sides.